Okay, so in this video I'm going to explain the theory and the ideas behind this hydroplaning skimmer, which is basically a hydroplaning outrigger. Hi, Mark Palmquist. I have another way of describing the advantages of the wingman or the trimaran with hydroplaning skimmers, whichever you want to call it. Everybody knows that in low speed conditions, a hull that is long and skinny is faster because it has less frontal area than a boat that is this shape. So a boat that is proportioned like this is going to be faster once the wind is above a certain level and the hull can hydroplane. But in low wind conditions, a boat like this is a little bit slower unless you kind of lean it and sail it on its edge like this. So what I have done is I have basically transferred some of the width, the planing surface, out to the leeward side of the boat. This skimmer is 30 inches wide. So technically I could remove, most planing hulls are about 4 feet wide. Some of them are even 5 feet wide. So imagine being able to take this hull and make it about half as wide and transfer that to a skimmer that is to the lee of the boat, that's above the water line, that doesn't touch the water until the boat starts heeling when it's needed. So in other words, the hull can be skinnier, and maybe not this skinny, but the hull, when there's not enough wind, the hull is still very fast because it's more narrow. And when the wind picks up, then all of a sudden this skimmer hits the water, and all of a sudden you have almost three feet more of hydroplaning surface area, and it's not underneath you. It's about 6 feet out in front of the CE of the sail. So in other words, my little sailing canoe, spark sailing canoe, if you think about it, the width goes from about 28 inches wide to another 3 feet, which is over 5 feet wide, which is more width than, let's compare it to the Oz Goose. So the Oz Goose is 4 feet wide, and you're sitting with your center of mass on the edge of the boat, and so there's a separation of about 4 feet. With this boat, you're 6 feet away from the hydroplaning skimmer. So technically, the Oz Goose has a sail area of 110 square feet. So I could actually, I've already figured out that I can put 120 square feet of sail on my spark sailing canoe, and it would be fine. It could handle it because it has the width. And so it has no disadvantage. So in low winds, the main hull is narrow and it carries all the weight, and it has less frontal area, so it has less drag. And then once the winds pick up, the main hull can no longer contain the heeling motion of the sail, but then the skimmer is basically deployed automatically when the boat heels and it touches the water. And then you're basically transforming from a shape like this to, a shape like this and this combined, basically. So why the short, stubby proportion? Why isn't this like long like a surfboard? Well, if you study windsurfers, a windsurfing board has to be long because when you start out, you have to have a certain amount of volume. And then once you get going, the faster you go, the wetted surface area shrinks until when you're going 40 knots, if you look at the wetted area on a windsurfing board, it's about 1/3 of the length of the board, or maybe even less. So I'm not starting out with the skimmer. I'm not actually starting out at 0. I'm starting out about 5 or 6 miles an hour. So I can take it and I can shrink it already to half. And then So now the length of the wetted area is about from here to here, and the faster you go, because the lift generated by the skimmer is so high, it's actually more than the sail can push the boat over. Your wetted area will shrink to this, and this will have so much lift that it lifts the main hull a few inches out of the water. Literally about half of the hull starts lifting out of the water. That's another way of looking at it.